So welcome back again to the third episode of Arithmetic Progression Solving series. In this video I've picked another two questions which are really good and you'll enjoy them immensely. The first, this is about the sum of AP, and this is about just normal, little playing with numbers, that's what we say here, playing with the variables, and we'll just manipulate it in such a beautiful manner so that even, you'll also be surprised that questions like this, questions can also be solved in this manner. Let's begin. The question says, if x, y, z are real numbers, satisfying the equation 25 into 9x square plus y square plus 9z square minus 15 times 5xy plus yz plus 3xz equal to 0, then x, y, z are n. They have given some random condition and equal to 0. They have equated the whole thing to 0 and asking what are x, y, z n. Well, since you might have a guess that we are doing arithmetic progressions that chapter, so answer A will be option A, that is AP. Well, you are absolutely correct. But if this comes in exam, you obviously won't know which chapter it belongs to. From how they have asked this. So for that, you need to learn how to solve this. Now let's multiply each term, that is 25 into 9 is 225. Can we write 225 as 15 square? Obviously, because 15 square is 225. So 15 square or 15x whole square we can write it, because x square is also there. 15x whole square, and 25 into y square is plus 5y whole square. I'm sure you have no objection when I write this. Plus 9z square is also 3z whole square. Are we correct? Obviously we are. And the next thing is 15 into 5 into xy, right? I'll write it as, since we already have 15x and 5y, I can also write it as 15x into 5y. Is that correct? Yes. Again, there's a minus sign, we multiply, that is 15 into yz. But if you see the combination of y and z, we have 5y and 3z. If you multiply this, 5 3s are 15, so we get the same thing again. So 15yz can also be written as 5y into 3z. Yes, we are correct. And finally we have 15 3s are 45. So 45xz can also be written as 15 into 3, that is minus 15x into 3z. Yes, obviously. Now this is something really awesome we have done, because what we can do at this point is we can write, we have to make this in whole square type of form, that is like 15x something like whole square, that way. So what I'll do is I'll multiply the whole equation by 2. Since this is also equal to 0, it doesn't matter what we multiply with, because that right hand side also it becomes 0 whatever you do. So I'll multiply the whole thing with 0, that is 2, with 2. So 2. You understand what I'm doing? I'm trying to make it in the form of a square minus 2ab plus b square, right? Now out of, there are two, 15x square plus 15x square, so I'll pick one, 15x square, 15x whole square, minus, I'll take this term, that is 2 into 15x into 5y, plus I'll take one of the 5y square, right? 5y whole square. What is this? 15x minus 5y whole square. Yes. So this is also in a way true. If I can do this for one term, I can do it for 2 more times, right? Once I've used in this, I have to use it once more also. So the next term will be 5y minus 3z whole square, and the final term will be 15x minus 3z whole square. Or I want to write it as 3z minus 15x whole square. It doesn't make a difference, since it is whole square. It doesn't matter at all. So this can be equated to 0. So if 3 terms which are squared are equal to 0, each term have to be 0, because this is never negative, this is never negative, this is never negative. So 3 positive terms cannot be equal to 0. When you add 3 positive terms, it is never equal to 0. So those 3 terms have to be 0. That is 15x equal to 5y, because this is equal to 0, so this becomes equal. 5y is equal to 3z, and 3z equal to 15x. Now let's see what ratio they come in. That is 5 times 3. So y is equal to 3x, and 5y is equal to 3z, and we have 3 times 5, that is z is equal to 5x, right? So we have this thing. Now I can also write this as y is equal to 3 by 5 z. Yes, obviously, yeah. So now 15x equal to, when I write, or we can do this also, we can simplify it in another way. 15x equal to 5y. We have 5y is equal to 3z. So 5y is equal to 3z. So we can come into simpler form here itself. So what I can do here is just simplify in a way. Yeah, so this becomes 3 times. We can write this in the form of ratio, that is x by 1 by 15 is equal to y by 1 by 5 is equal to z by 1 by 3. That should be okay. If I multiply with so I'll multiply 15 here, 15, 15, 15, I'll multiply everywhere. So x by 15 by 15 is equal to y by 15 by 5 is equal to z by 15 by 3, right? So this becomes 1, this becomes 3, this becomes 5. So x by 1 is equal to y by 3 is equal to z by 5. So x is equal to, if I call it some constant k, x equal to k, y equal to 3k, z is equal to 5k. You can see common difference is 2k, and hence k, 3k, 5k are in AP. So option A is perfectly correct, and that's what we need for this answer. Let's move on to the next question, which says, if the mth term of an AP is 1 by n and nth term of an AP is 1 by m, then what is the sum of the mn terms? Now they are telling am equal to 1 by n, and they are also telling an equal to 1 by m. Is that correct? Yes. So am can also be written as a plus m minus 1 into d. This can be written as a plus n minus 1 into d is equal to 1 by n is equal to 1 by m. That's correct? Yes. So what I do here is I'll subtract the equations such that a and a gets cancelled. So what I'll do is I'll subtract this, anything, both of them, it doesn't matter. So I'll subtract this from this. So that is a plus n minus 1 into d is equal to 1 by m, and a plus m minus 1 into d is equal to 1 by n. I'll subtract, so this and this become get cancelled. This is minus and this is minus. So d is common, d into n minus 1 minus of m plus 1 is equal to 1 by m minus 1 by n, right? Now 1 and 1 gets cancelled, so d into n minus m is equal to, if I take LCM and do it, n minus m divided by mn. So these two gets cancelled, so I'm left with common difference is equal to 1 by mn. So that's what I get if I do this. That is common difference, d is equal to 1 by mn. I can substitute it in any one of the equations to get the value of initial term, that is a also. Let's substitute in this. A plus n minus 1 into 1 by mn equal to 1 by m. Is that correct? Yeah. So a plus, I'll multiply n by mn, that becomes 1 by m minus 1 by mn equal to 1 by m. So 1 by m gets cancelled. I am left with a minus 1 by mn is equal to 0. So a is equal to 1 by mn. So we have common difference also equal to 1 by mn. We have a also equal to 1 by mn. Now what do we need? They want sum of first mn terms, that is Smn is equal to what? That's what they want. We know that formula for Sn is equal to n by 2 into a plus l, that is 2a plus n minus 1 into d. So if we want mn terms, that is Smn is equal to mn by 2 into 2a plus mn minus 1 into d. Yes. So Smn equal to mn by 2, that is I'll keep it the same way, mn by 2 into 2 times a is mn, 1 by mn, sorry, mn plus mn minus 1 into d is again 1 by mn. So it comes out to be this way. Now if I multiply this, these two gets cancelled, so it becomes 1 plus mn and mn gets cancelled when I multiply it inside, so I get 1 plus mn minus 1 whole divided by 2. So this, if I take LCM, I get divided by 2 plus mn minus 1. So 2 minus 1 is 1, so 1 plus mn whole divided by 2. So the final answer should be option B, because we have 1 plus mn whole divided by 2, and that's what we get here too. I hope you have enjoyed a lot watching this video and learned loads with me today. So please like, share and subscribe to my channel, and press the bell icon also so that you get notified whenever I post the next video. And also please download the Bolo app from the link given in the description box from Play Store. and follow me on my profile, whose link is also given there, along with the comment section, where you can book one-on-one video sessions with me as well as other experts present on the platform who are just there to help you all out at all times, and get your queries answered there from me, and get discount coupon which is given in the description also. And finally, thanks a lot for watching this video. Thank you.